Hey everyone, Morgan here. So we're looking at the back side of redox number 4, where we're talking about electrochemical cells, and we're seeing a nice diagram here of a cell. And the first thing that I notice are these arrows telling me which way the electrons go. And I know right away that electrons, leave the anode because it's negative, and they go to the cathode because the cathode is positive. Now, technically, this whole thing gets called the cathode, but in reality, it's that piece of metal that's labeled A. That's where the change is actually happening. Same thing over here. The anode, that piece of metal E that's labeled. So, label the anode and the cathode. If the salt in the salt bridge is KNO3, which direction do the K plus and the NO3 minus go? Anions always go towards the anode. So the nitrates on this side and the potassium ions on that side, because cations always go towards the cathode itself. Now, if the solutions are zinc and magnesium, calculate the EMF of the cell. So that's when we go to one of these tables, And I kind of remember a couple of the numbers, not a lot of them. Magnesium is more likely to oxidize than zinc. So Mg is going to go to Mg2 plus 2 electrons, and that E naught is 2.37 volts. So zinc 2 plus 2 electrons going to zinc. That E naught is negative 0.76 volts. So when I add them up, I get 1.61 volts, and that's what would read on that meter right there. Now that means that, this one, E, is going to be the magnesium, and this one labeled A is going to be the zinc. The solution over here would be zinc 2 plus with nitrate, NO3 minus, and the one over here would be Mg2 plus with NO3 minus. So now let's look at these questions down here in number 12, where we're calculating more of the EMFs. So just like we did up above, Mg goes to Mg2 plus 2 electrons, and the E naught is 2.37 volts. Zn2 plus 2 electrons gives me Zn. The E naught is 0.76 volts, and when I add that together, I get 1.61 volts. So here the Fe will turn into Fe2 plus 2 electrons. Zinc 2 plus 2 electrons will give me Zn. So if I go to that table again and look up these values, this is negative 0.76 volts, and then this first one will be 0.44 volts, and that adds up negative 0.32 volts, and that's a non-spontaneous reaction. Because that's negative, this doesn't happen. Another one, copper goes to copper 2 plus 2 electrons. The E naught is negative 0.34 volts off the table. Mg2 plus 2 electrons goes to Mg. The E naught for that is negative 2.37 volts. Ooh, that's going to be a very negative number here. Let me grab my calculator. Negative 2.37 plus negative 0.34, and I'm getting negative 2.03. And run that again. Negative 2.37 plus negative 0.34, and it's negative 2.71. I typed something in wrong there the first time. Thought that wasn't right. 2.71 volts. Very negative, not going to be spontaneous. So, lithium can turn into lithium plus an electron. Copper 2 plus 2 electrons gives me copper. Now, I need to make the electrons balance, so I will multiply this by 2. But that does not have any effect on the EMF. I don't change its value from the table. For lithium, that value is 3.00 volts, and this copper is 0.34 volts, and that is a positive 3.34 volts and a very spontaneous reaction. The nickel goes to nickel 2 plus 2 electrons. The Mg2 plus 2 electrons gives me Mg. E naught equals. Okay, so for the magnesium, I already know that's a negative 2.37 volts. And for the nickel, I can look that one up, and that's 0.25 volts. So this adds up to be a negative 2.12 volts, okay, which means it's non-spontaneous. Here, Br2 is going to turn into 2Br minus. That's 2 electrons on that side. 2I minus gives me I2 plus 2 electrons. On the other side, all right. So now, the value for the bromine comes out to be, I check my table here, that's not one I'm remembering off the top of my head. That is a 1.06 volts. And the other one is a negative 0.53 volts. Add that together and I get 0.53 volts. It's spontaneous. F2 going to 2F minus. That'll be 2 electrons over here. 2I minus going to I2 plus 2 electrons. Okay. E naught equals. E naught equals. This is huge. It's a 2.87 volts. And this one is a negative 0.53 volts. So that comes out to be a 2.34 volts if I'm adding that up right in my head. Okay. There you go. Get a lot of practice in on this. The biggest thing I can remind you of, like with this one, you might multiply this equation by 2 to make the electrons cancel, but do not change the value of the EMF. All right, thanks for tuning in. This is Morgan signing off.